So now, here is the chance to ask more detailed questions than maybe we've asked so far. Let me start things off again, if I could use the privilege, to the question that I would have on this topic of geothermal energy from mine pools is there any, or what can we say about the possible treatment? Can treatment of the mine pool water, if it needs to be treated, can that be done in conjunction with its geothermal use?
Well, I think that the best thing about it is that it brings the water to the surface. Treatment plants bring the water to the surface. I know that in Great Britain, what they're doing with the plants that they're using for geothermal, they're using the raw water to do for the geothermal systems, because when you clean the water, you don't completely clean it, and so there's a lot of sediment that's still in the water when you're discharging it. I mean, it's sediment that comes out in the stream, so that there's not a big problem with that. But that sediment in a treatment in a geothermal system means that you're going to have to do a lot of maintenance in that heat exchanger. Now, the heat exchangers, a lot of them use a heat exchanger that's got plates, and those plates you can take them out and clean them. Okay. So that eliminates some of that, but actually the best thing to do is if you can nearly completely keep the oxygen out, use the mine water and put in a good stainless steel heat exchanger. The heat exchanger keeps all of the mine water from the heat pump itself, the expensive stuff. The heat exchanger is pretty much a disposable type of thing. And the heat exchangers that they use that's what they're doing in Great Britain.
And you mentioned about the oxygen levels. Could you just expand on that? Why is that so important?
When you get oxygen in the water, it causes the precipitation of the iron oxide, and that can clog the system. It builds up on pipes. Okay. It builds up even on plastic pipes. But on anything that's rough at all, it certainly builds up. And it builds up on heat exchangers also, and lessens the ability of heat exchangers to work.
All right, very good, yes. Now, as questions arise, I'm going to walk over to so we get everything recorded.
There are some heat exchangers that people are using in Great Britain in the smaller systems that they use right in the channel that keeps that clean, so that you don't have that problem.
So the UK is really ahead of us by quite a bit.
They're doing so much that yeah, they're doing real projects. They're not just pilot projects or anything. These are real things.
Okay. Let's see. Then let me jump in with the next one. Let me pass the mic to you, Chuck.
So there are actually two questions or comments. Questions from this table is what's going on in the UK? I said it's the Coal Authority. So my understanding is that's a government entity. Is that correct?
Well, there's a lot of government money that's going into their mine drainage department. They're called it would be like our abandoned mine, like our BAMR. There's a lot of government money that's going into it, but there's also a lot of private capital. Okay. Over the years, there's been a lot of work done that was completely private capital. There's several big industrial parks that worked in the lead mines, above the lead mines and tin mines that have mine water geo-exchange systems that are put in. In fact, there's the big heat pump company in England has a plant over top of one of the old lead mines that their whole industrial park is heated and cooled with, mainly heated.
Yeah,
Because
so,
they're not, concerns for cooling in Great Britain have not been very great.
yeah, so I actually was thinking about the issues with access and, you know, who owns the mines and who has the authority to, you know, that's why I made a comment about the coal authority. But I have a second question. Going back to your.
Back on that's not a real concern in Pennsylvania. Who owns the mines doesn't matter to mine water,
Well, okay, so.
because who owns the surface owns the water. Who owns the surface owns the water in Pennsylvania.
Well, no one owns the water. It's.
Who owns the surface owns the water in Pennsylvania.
Yeah, well, there's,
Scott Roberts said that who owns the mines owns who owns the surface owns the water.
yeah.
And that's the way it's been ever since.
So,
Along with that, to add to what he said, in West Virginia, there was some legislation passed that if you're, there was the question, like when Zemkevich is doing that, removing the rare earths, whoever is treating the water owns the water in that situation. So they get the benefit from it
Okay,
and the
so-
liability.
getting back to the question about the, you know, the water quality and the, you know, how to, you know, no oxygen. So that's with an open loop system. And then the closed loop system, which is where you're using like pipes and some sort of a heat transfer fluid, we can avoid those concerns, correct?
You can, but that's much more capital intensive than the other.
It is, because you have to put underground piping.
Because you have to put in a lot more piping. You have to put in a lot more piping. Plus, you have to still have to worry about bacterial growth. You have to worry about any, you know, the coating of those that piping also, so that you can have the a closed loop system. It can plate also, and you can have that underground that you have to clean those pipes out.
Okay, thank you.
Yes, Dan.
You said that a lot of this was really looked at in the late 1970s, and I'm wondering why haven't we seen any major development in our country, at least in our area, since the 70s? And is it because there just wasn't, like, is the upfront cost too much? And then just real quick on that, then, do we think that there's something now that would make it economical, like like an energy need or something that's unique now that would make this actually happen?
I don't see anything, Dan. The first question is, since the 1970s, well, it was actually 79, 80, 81, the Department of Energy put a lot of money in. There was a lot of money was put into the northeastern Pennsylvania for these projects. The grant, people don't seem to want to do a project unless they get a grant. I mean, it doesn't matter freaking anything anymore. People want a grant. They want some free. We want free money. With free money, they do something. If they don't get free money, they don't do something. But there is. I think that the thing that might happen today is exactly what we're talking about as far as the data centers. Data centers are going to need a lot of water, and people are running out of water in Hazleton already when they have the Geothermal tunnel underneath them. And so that I think that that's going to be a big thing, is that people are not going to want their drinking water to be used for data centers.
So let me ask, before I do,
Yeah, my question is, what information, or maybe we're just not there yet, or it's not a concern, but maybe it's a geological perspective more, but what is the relationship between geothermal development for mine pool access in any kind of risk relationship with subsidence events? So thinking about, like, for a data center that needs, you know, the most stable kind of ground for any of that fragile computing equipment, is there a risk in the pumping system decreasing the water level that might increase subsidence risk, or the drilling that's required in the rock formations.
Well, system, okay? The systems that they're talking, if you're talking about a pump and dump, there's no decrease in water level. And so there's no, I'm not sure that water withdrawal is a real big item with subsidence anyways. I think that most of the subsidence in our, at least in the anthracite region where the mines have been abandoned for a long time, most of the subsidence has happened that's going to happen. I mean, you're going to have potholes, but you're not going to have large subsidence issues. But I think that withdrawal of water is not an issue because you're putting the water back in.
And it also depends on the type of mining. So with longwall mining, I was talking to a DEP person. They said 90% of your subsidence within a longwall mine will happen within about a year, and then at the 30-degree angle of effect beyond the mining, it's within 3 years. But you're not going to, I don't know that they're going to put a multi-million, $100 million plant over top of a subsiding area. In the Pittsburgh, what we're talking about, he said that the withdrawal of the water isn't a problem. The problem with the Pittsburgh mine up there is they got to treat the water. It's going to come out and flow into the Mon River or into the Ohio River. So that's not an issue to worry about. And a lot of that mining, and especially around the Morgantown and Clarksburg area, is so old, like he said, what subsidence has happened has probably happened.
And the other thing is like you said, is that most of this all the water's discharging, almost all of it anyways. And so that you're not really removing water. Probably a big benefit would be if somebody would come in and say, well, we'll treat the water and discharge it to the stream. And then people might be happier about the whole thing than anything else. But I don't know that's going to happen.
Taylor, let me ask you, so in your presentation, you showed that the height of the tower is something to be minimized as best you can. But the shape, that was a very interesting graphic, visually very interesting, how you showed the contour of the excavation that houses but if the solar panels are sort of, how is that optimizing the solar radiation to them if it's sort of along the wall of the excavated area?
Yeah. So with that configuration, there's not too much variation between how they would act within a pit versus how they would react traditionally on the ground, just in the sense of they'll still be able to move their full effect. So with that pit, with that shallow of a slope for that configuration, the heliostats would still be able to move and the sun would still be able to be optimized within the pit, just because majority of that solar production is coming from kind of your middle of the day where the sun is directly overhead.
Okay, I see.
So are those heliostats flat or are they convex?
They can be either. For the sake of our model, they were flat.
I have a question about that. And so, good modeling, all that, because I've never seen in Pennsylvania a 500-foot dry pit. Okay, so I've seen that in the desert, Peru, and in Utah. And so I'm just curious, is there a thought that your research applies to Pennsylvania, or is this really going to copper mines and gold mines in areas?
Yeah, so definitely easier for that application in those desert regions. We're doing some work right now in terms of case studies in Pennsylvania, whether we are able to apply this in terms of draining those pits and seeing what sort of production we can get from them. It's not necessarily in that case study level at the moment to say that it's been done and is a guaranteed thing that it can be applied. But yeah, that's something that we are actively looking into.
Tim? Yeah, please.
sorry. I had a question about actually databases, because the West Virginia example was excellent. In the context of a lot of these changes for the energy system, there's just this tremendous change happening, and there's all this investment that's going to happen, right? We have to triple our grid scale energy storage in the next 10 years. We've got all of this billions of dollars of investment being spent. As geothermal energy is being transformed, and as the other systems we're going to be talking about, access to that data is this really interesting pinch point where in Michigan, we have an abandoned mines database in the state that is like the one in West Virginia in a sense that it is confidential and carefully controlled as confidential information. Our neighboring states in Minnesota and Wisconsin put theirs out on the internet. The Geological Survey from Minnesota just emailed me their abandoned mines database GIS layers. And meanwhile, you have these companies that are looking to invest hundreds of millions of dollars in projects in energy, some of which beyond abandoned mine lands. And I've been trying to find ways to articulate to people that there are engineers, like the people in this room, reviewing these databases right now, looking for investment opportunities for these companies. And if the data's not there, you're not even making the first round of cuts for consideration. I'm wondering in Pennsylvania if people are aware of this, like by comparison from West Virginia, who have made their data available as much as they can with this excellent database. Are any of the other coal regions?
Pennsylvania has a great mine data system. I mean, there's lots of abandoned mines. Access to the records. They're all on a state system also. I think that the biggest problem is the lack of mining engineers. I think that people are going out and saying we can do these things with this mine water when it doesn't make any sense to do these things. I mean, people are talking about pumped storage in using mines for pumped storage. Well, when people are pumping billions of waters per hour back and forth from one place to another, and not looking at what the rock structure is, there's going to be a tremendous disaster someplace along the line that's going to really put a stop to things, just like 3 Mile Island did to nuclear. I think that's what's going to be happening. I think that's one of the most frightening things that's happening, because people are spending a lot of money, like in Sweden, on pump storage with underground mines. And I can't believe that anybody's done really extensive enough study of the modeling of what that underground structure is, or know enough about that underground structure to be able to do that. And that's one of my biggest worries is not having the knowledge of what the hell they're talking about. I mean, it's great to pull something out of your butt, but you should think about it a little bit.
Well, maybe we can hold off on that because Professor Scarlett will address that very thing, that topic.
I'm aware of your work.
Along that line, I had a discussion with the PA state geologist. Along that line, I had a discussion with the PA state geologist about a month ago, and there's people in your all's PA legislature that are interested in a coal bed mapping-like project for Pennsylvania, and she was kind of picking my brain as what you need to do to get there. And I was like, well, money, that's the big thing, money and people. So I won't say it's easy to do, but it can be done.
Yeah, Jim, and I read you made your opinion clear also during your presentation, and I read that in whenever your reports, that your skepticism, and that's understandable, about push, right? But I guess from me being a layman, I might come back and wonder, well, again, we can address this later, but are there things you can do if it's not a hard rock mine, but things you can do, and maybe they're not economic, but from an engineering perspective, are we stuck?
I'm not an engineer, obviously, but if anybody's been underground in the coal mine, you're going to have coal, and you're going to have partings, and you're going to have a roof and a floor. Quite commonly, the floor is a clay stone, which is very water soluble, and if you run a lot of water over it, you're going to, well, not dissolve it, but you're going to erode it away. You have blockings that are built up with timbers that as things move, the water moves, it's going to move that stuff around. So imagine if you would a 5-foot pipe that's pumping water up and down, and you fill it up with a bunch of, 10-foot toothpicks, railroad ties, and mud and rock, and every time you put water down that hole, you're going to have tremendous amounts of energy that are being expended on the sides of that mine. The roof is probably, it's either going to be a shale, a clay stone, or a sandstone. Sandstone to be the best situation, but you don't often see that. It's usually something soft and breakable. The roof is held up with roof bolts on whatever the engineers decided to do, but as you start tearing into that and breaking things are going to collapse. So it's not going to be, I don't think it's feasible in at least our geology.
Well, we'll hold off on that further, but this afternoon, that debate could be had. The challenge has been thrown down, and between Tim Scarlett and his colleague, Thomas Johansson, who will be with us remotely, we can address that more. But no, this is good. This is, I guess from the point of view of people such as us at Shamokin Creek Restoration Alliance, we just want to know what our options are. And so a full exploration like we're doing here is highly valuable to us. So again, we value your opinions, and we want a full debate is kind of what we're after, so that's good.
I think that Shamokin Creek certainly has an opportunity with mine water exchange, geo-exchange, because of the closeness of water to the surface, the fact that a lot of water is being discharged, that stuff can all be accessed. And so all of those places, you have those things that certainly municipal structures, certainly any new developments, that there's a chance to use the water for those purposes.
So, Taylor, could I ask one more of you that, just again, a layman's question, I guess. Why are AI centers, why are these facilities so much of a heat generator? Can you explain that?
Beg pardon?
Why, so the AI centers that need all this cooling, why is so much heat being generated in the first place? Well, maybe is it because of this? Okay, I have an example, a real world example. So, as I said, I worked for Amtrak, and one of the things we did was we always monitor the track geometry for safety. Is it getting too much warp or whatever, too much alignment, profile deviations? And we do this every 2 weeks. We run a track geometry car over it at speed, at the revenue speed. So we go as fast as 150 miles an hour. And I noticed that those microprocessors that are part of the track measuring system are really, they're smoking. They're just barely able to keep up with the data because we measure every foot along the track, every foot for hundreds of miles, right? Boston to DC. So maybe it's just a feature of that you're asking a lot of these electronics, and that's the case here. Maybe is that what we're talking about?
Yeah, I would venture to say so. I might not be the best person to ask in terms of data center stuff, just because we're still in those early stages of this project. But yeah, I would venture to say so.
I was just curious.
Well, any of you guys that have kids that have gaming computers, and they want to soup them up and get them faster, and the biggest problem is they make heat, and that's just one computer. Imagine, a room 10 times this big full of that stuff. It makes a lot of heat.
And if they're using water that can't go back and get cooled in the underground, it goes to it goes to a cooling tower that's where the heat goes.
Yeah.
And that when the cooling tower goes, it's water going. That's water going into the air. That's how it cools.
Okay. Interesting. Yeah. Well, by the way, we're Amtrak. I'm retired from there, but now they're going to go 150. They are going 150 miles an hour top. They're about to go 160. So yes, we have high-speed rail in this country. It doesn't stay at that level for very long, but it goes up and then it comes back down again. But it does hit 160, or it will soon will. Any last question? Yeah.
No, just on the heat thing with AI, is the processors itself inside the computer, even home computers, they have a fan right attached to the processor. And there's like a little thing you drop on there, like an oil type thing. If you don't put that on, the computer won't run. It gets that hot. It has to vent that heat out. Even a home computer is like that. That's how hot the little processors get.
So it's true, yeah.
Yeah.
Good. All right, maybe one last question? Oh, there's a few last questions. Let me go back to this gentleman here.
The data centers, they're going to be putting a lot of hot water into a mine pool. How much temperature increase is there going to be from a data center, cooling a data center? That's my first question. The second question is that going to have any effect on the iron and sulfur reducing bacteria?
Good question.
I agree.
No, I believe, Jim, that a few data centers are not going to cause any problem at all. But I think that there's so damn many of them being built in Arizona and California that I don't know how. I know it is a hot air thing right now, but 45 data centers are not going to make that much heat compared to how much water we have. I think that the water going back into the ground is going to be not insignificant as far as changing temperature, but certainly at some point there's a change, and I think there's certainly we could do a lot of data, do a lot of modeling that's not being done. There's a lot of information that isn't available right now on mine pools that needs to be, and I think, Tom, you're going to talk about that later on. But there's certainly stuff that needs to be done before a lot of work is done. But right now, nobody's doing anything. So, I mean, it's kind of like chicken egg question.
Bobby, you had a question?
Yeah, for James, you mentioned that the confidentiality clause that was put in the law in West Virginia. Do you have an example of what would be confidential that's as opposed to a surface mine permit and a mine plan being put in that is either in electronic form or it's a part of your active mining permit? Why wouldn't that information be publicly available at the mining offices like it is in Pennsylvania?
So, if anything comes to us from the West Virginia State Tax Department, it's considered a tax document, whether it's a drill hole or whatever. They have a property division. They will send us any data that they receive from a coal company, but we have to keep that confidential in perpetuity because it's considered a tax document. Now, that's not to say we won't get a copy of it from somebody else and then we can make it non-confidential. If a coal company gives us data and requests it to be kept confidential, it's kept confidential. I think the original intent of the law was 5 to 10 years, but a piece of data gets so embedded into our data that it is such a pain in the neck to get it out that once it gets in, it's confidential. It's not. I told the people that work for me one of these days when I retire, if they want to do it, knock yourself out. But right now, it's not worth our time. It would take everybody's time all the time for a couple years to pull that stuff out. Now, there have been some exceptions. If an individual is a large property owner, there are drill holes on their property, and those properties, or those drill holes are confidential in our system. If they can provide documentation from the property owner that they indeed own the property, and we have these drill holes on there, and we give you permission to give it out, then we can give it out.
And I think that in Pennsylvania, that we have a lot of places, there are some places that we have property owners that have kept their mine maps confidential as far, they've been allowed to put them into a system, but they're not into the state system that's available to the public. I think that there's several landowners that have done that.
The West Virginia Office of Miners Health Safety and Training are the ones that collect the underground mine maps, and they can that department considers those data confidential. So if I wanted to go out and look at, say, the Lear mine and see that mine map, they will not show it to me as a public citizen unless I own property over it, and then they will only show you the information right under your property. And they won't show you the whole mine map. As soon as that mine is no longer in operation, then it goes to Office of Surface Mining and the feds, and you can get all the data you want off of it. It's kind of maddening at times.
A good resource is the EA Mine Map Atlas, if you haven't been there, because sometimes you can find those images for the abandoned mines.
Yes, like really late for this question, but for your presentation, some of those the geothermal heat pump build, like you were talking about Indiana and some of those other places, and I think you showed that one rec center. Is that something that buildings can be retrofit with that, or is this only possible like on new construction?
Oh, basically anybody that has a ductwork system in their house could use could use a geothermal heat pump.
You have to be right. I mean, this is
In fact,
sorry. I don't know anything, so I'm asking like the stupid.
There are geothermal heat pumps that are water to water, and so you could, if you have radiators in your house, you could use them.
And do you have to be right on top of it? Like what distance?
Well,
can
you have to be on top of it because that's where you get the water from. You own the water that's below your property. You don't own the water that's below your neighbor's property.
So what would you say is like the biggest barrier to more of this happening? Are people not willing to put like you were saying?
Right now, there's nothing.
So
in Great Britain, there is. In Great Britain, there is a permitting process for this thing. I don't like to say that in front of too many state people, because
permitting process is a barrier, or not, or a lack of one.
Well, any permitting process is a barrier to use.
So what's a barrier right now to more universities,
None.
more houses, more?
Money right now.
Just because there are upfront costs and people won't look ahead to see the long-term gains.
Right now, there's nothing.
People are comfortable with electricity. They're comfortable with what they have. People don't like change. That's a lot of it, I think.
Yeah, well, mines are bad anyways.
Yeah, exactly.
I just interrupted. So if you did have a geothermal in your house, do you still need a supplement of another energy source?
No.
Or can you get full from the?
No, it's the only reason that your air source heat pump needs a supplemental electric grid in it is because at a certain temperature they start to be less efficient, and so that they kick in. There's the emergency heat comes on your air source system, but geothermal there's no practical problem. That one system that I showed that was in South Dakota, South Dakota, they're the same thing. They operate between 44 below zero to 100 degrees all the time for 20 years. Ground's 55 degrees. Mine water's 55 degrees. Ground's changes a little bit, but not a lot.
So like if we're looking at mine pool temperatures, is there value in finding something that's 2 degrees or 1 degree? Is there value in finding cooler water?
Not really. Because what it's doing, it's changing the temperature 5 degrees, water coming up, water going back down, changing 5 to 10 degrees. I always talk Fahrenheit because I don't know that other stuff.
Maybe in the winter versus
But that's
summer.
what, 40 feet by 40 feet.
Depends on when you need it.
Don't give me that 12.1 meter shit.
Oh, I know. Yeah.
Okay, well, that's right, I meant to get back here.
I get a lot of. So we talked about the water ownership, but if you want to tap into a mine pool and there's any kind of structural issue that occurs with the mine, who, if it's a abandoned mine, are you still shielded from any liability? Like, is there any pathway that in the future someone could say, your geothermal system is what caused this, and you didn't do the right steps to, protect the structure of the mine or whatever, and because the company no longer has liability, like, where does the liability of the mine structure itself fall if you're using the structure for your geothermal?
Good question.
I would say that attorneys will figure out ways to go after you. You're
Is
never
that a
shielded
barrier
completely.
to increased access as companies are
Not
concerned
yet.
about liability?
That's something that they'd have to go to state legislatures and get some rules passed.
Yeah.
There's lots of things that are not, if you have to put a district heating system in right now in Pennsylvania, I don't think that there's a mechanism to charge for heat. There's a mechanism to charge for electricity, there's a mechanism to charge for gas, but there's not a mechanism to charge for heat. So I'm not sure how that all would lots of lawyer work. Lots of legislature work, lots of that type of thing. But it's got to happen first.
Right.
I mean, you don't make up rules before there's any reason to make up rules. And people will make up rules.
Well, we're recording this.
Oh, okay. And this is sort of a question out of the area I'm supposed to be, confined to and professionally or whatever working, but non-technical. I've heard geothermal, I've heard geo-exchange. I talked to Mike a little bit about this. I used to think of this as groundwater heat pump. That's where I first read about this concept because I'm a groundwater hydrologist, so that's where I'm coming from. But I think the words are really important for the larger community to, get a hold of this and start to understand what they're talking about. Everybody's getting the mini split now. It's a heat pump. That terminology means something to a lot of the lay community, and I think I would propose that we use that term for this process that we've called several names here this morning. I think geothermal, to me, is a source of energy. Heat pumps are not a source of energy. We need to be clear to people, we're not selling them free energy. I mean, you're not getting free energy, you're getting efficiency. You're using another energy source more efficiently, whether it's electric or wherever it's generated. You're heating and cooling your house more efficiently. You're saving money. That's something, again, that people can understand. So I guess I would propose to the community that we try to pick a terminology, at least for that specific technology, and kind of, it'll help a lot with, I think, moving things forward with using it.
I agree, but I think that, like I said before, I think that one of the problems is inventing a new word. You have to start explaining people what the hell this is. I think the word probably is geo-exchange. I don't know that that's exactly the word that it should be, and that's much more correct. But I've given several talks where I spent half of my talk talking about what geo-exchange is before I started talking about using geo-exchange and then using mine water for geo-exchange. It says, so it doesn't do it in a half an hour. But geo-exchange is the word, I think. Who all knows what geo-exchange is? Bree?
Maybe we should probably close this out, but Taylor, let me ask you to give the last word and take us to lunch by Could you describe a little bit about your organization, Reset? What is the acronym again? And what is its overall mission? Because it sounds like exactly what a lot of us in this room are interested in.
Yeah. So Reset is a center at Penn State. It stands for the Repurposing Center for Energy Transition. It was founded, I believe, about a year ago within the Earth and Mineral Sciences Department at Penn State. And our main goal is repurposing fossil fuel infrastructures for renewable energy systems with a primary focus on abandoned oil and gas wells as well as surface and subsurface mines.
Yes, we want to keep up with that, your organization there. All right, well, let's have a hand for our three presenters, if you would, please.